Antarctic melt could stabilize vital ocean current. Despite climate change, melting ice in West Antarctica may act as a surprising buffer against the collapse of a crucial Atlantic Ocean current, even as climate change intensifies. While Greenland's accelerating meltwater threatens to slow or halt the Atlantic Meridional Overturning Circulation, AMOC, the system that keeps Europe temperate Antarctic melt could, under certain conditions, preserve this vital current. However, this doesn't negate the broader climate crisis, as even a stabilized AMOC won't prevent significant warming and sea level rise. The Atlantic Ocean current at risk, the AMOC functions by carrying warm surface water from the tropics toward northern Europe. As this water cools, it sinks and flows south, redistributing heat across the globe. This process transfers roughly 1.2 petawatts of energy, the equivalent of 1 million power plants, keeping Europe significantly warmer than regions at similar latitudes. The influx of lighter, fresh water from Greenland's melting ice sheet disrupts this sinking process, hindering the AMOC's function. A collapse of the AMOC could trigger severe consequences, including winter temperatures plummeting to -50 degrees C, -58 degrees F in northern Europe, higher sea levels along the U.S. East Coast, and more severe droughts in Africa. Some models predict a shutdown within decades, while others suggest a weakened but continuing current. Iceland has declared an AMOC shutdown an existential security threat, underscoring the gravity of the situation. Antarctic melt as a potential stabilizer. New research indicates that the timing of Antarctic meltwater could play a critical role. Simulations by Sacha Sinnott at Utrecht University reveal that if Antarctic meltwater arrives centuries before peak Greenland melting, it could prevent a total AMOC collapse. The Antarctic water would weaken the current for several hundred years, but allow it to recover over the next 3,000 years. This effect occurs because as freshwater from Greenland accumulates, the sinking point of dense AMOC water shifts southward. Early Antarctic meltwater could then help the current regain strength as Greenland's contribution diminishes. This finding highlights a previously underestimated connection between Antarctic melt and the AMOC's stability. Limitations and broader implications. While potentially stabilizing, Antarctic melt doesn't offer a climate solution. Even if it prevents an AMOC collapse, it would still contribute to up to 3 meters of sea level rise, flooding coastal cities worldwide. Stefan Rahmstorf at the University of Potsdam emphasizes that preventing one catastrophe doesn't negate the impact of others. The study's findings also need further investigation. More complex models are needed to account for potential feedback effects, such as changing wind patterns and expanding Antarctic sea ice, which could alter the results. Louise Syme at the British Antarctic Survey notes that the connection between Antarctic melt and the AMOC was not fully understood until this research. The future of ocean currents. The accelerating pace of climate change demands a comprehensive understanding of interconnected systems. Even if drastic West Antarctic melt prevented AMOC collapse, the broader consequences of rising sea levels and extreme weather events would remain. The study underscores the urgent need for global efforts to reduce greenhouse gas emissions and mitigate the worst effects of climate change. Despite the potential for Antarctic melt to provide temporary relief, the long-term outlook remains grim. The study serves as a stark reminder that addressing climate change requires systemic solutions, not just hoping for natural buffers to emerge.